Hello, welcome to another screencast. I'm doing this live in front of my period 2 anatomy and physiology kids, so if you hear anybody falling over, that's because they fell over of boredom. So in the other screencast, we've dealt with this already and this and this, and I want to focus here on endocrine or hormonal mechanisms that are regulating the cardiovascular system. So let's just do it. I know we haven't done the endocrine system formally yet, but some glands that are going to, you guys don't have this one. It's in another packet, so don't worry too much about that at the moment. So glands that are going to be involved in secreting the hormones that we are curious about here today. One is the pituitary gland, particularly the posterior part, because we're going to be talking about ADH. So the posterior lobe of the pituitary gland. We're going to be dealing with the adrenal glands here, and specifically a little bit about the adrenal cortex. Right? And the heart itself is also going to be releasing some of these hormones, and it's right here. So this ANP, this atrial natriuretic peptide. Right? So just to give you a visual as to where these things are coming from, you've got adrenal glands that are involved here. You have posterior pituitary glands that are involved, and then you have the heart itself. The cardiac cells of the heart itself. Also involved will be cells of the kidney, and we're talking here about EPO or erythropoietin. So the hormones, again, these are, some of them are short-term effects, and so over the short-term regulation, you have norepinephrine and epinephrine, which are from the adrenal medulla. Right? So these are short-term effects. But the long-term effects are going to involve ADH. So this is antidiuretic hormone. There's going to be long-term effects by an enzyme called or a hormone called angiotensin 2. Then there's one called EPO or erythropoietin. So erythropoietin is produced here by the cells of the kidney. And these three all deal with hypotension. So these are all hypotension situations. So when your blood pressure is lower, these hormones are going to be secreted and help play a role in regulating. Then the fourth one is the ANP, atrial natriuretic peptide, and ANP is going to be released when you have a hypertensive situation or blood pressure is greatly increased. Right? So it helps to at some point go back and think about, all right, why might blood pressure be lower? Why might the blood pressure be higher? Blood pressures lower, leading to hypotension, would be if you are, this isn't a good place to do this, but we'll just do it over here. So if you are hypotensive, you have low water in your plasma, you might be dehydrated, low blood volume, you might be losing blood, right? Hemorrhaging or slow hemorrhaging there. Right? You might be extremely vasodilated as well. So the big two, right, blood pressure, low blood pressure situations are these, and then you might have this vasodilation problem as well. Hypertensive situations would be if you are overly hydrated. If you are also dehydrated, so this could also cause a lower hematocrit. You might also be hypertensive if you have increased blood volume, so more red blood cells, more white blood cells. Right? For some reason, you have some sort of blood cell formation disorder. Right? So regardless of what the cause of the hypo or the hypertension is, the body is going to detect these changes outside of the homeostatic range and then do things to correct that. Might be a good place to pause and sort of summarize a little bit there. So if we look at first the hypotensive situations, right? So when there is hypotension, this is the stimulus, right? So we have a decreasing blood pressure, decreasing volume. This is the stimulus. And so over the short term, and this is dealt with in other lectures, right, is that we have this sympathetic activation, right, and releasing epinephrine, norepinephrine. This is a neural pathway, which we've discussed other places. We want to focus here on this long-term solution. The long-term homeostatic mechanisms involve endocrine responses by the kidneys and other endocrine glands, etc. So this lowered blood pressure, lower blood volume is going to stimulate the kidneys to release this enzyme called renin. So this is a little bit of a detailed mechanism right here. So what happens is you have a substance called angiotensin ogen, and this is dissolved in the plasma. So angiotensinogen, I spelled that wrong. Angiotensinogen is converted to angiotensin 2 by an enzyme called renin. So again, you have angiotensinogen, which is dissolved in the blood, in the plasma. When the kidneys detect lower blood pressure over the long term, this substance renin is secreted. Renin is an enzyme. This renin will convert angiotensinogen into angiotensin 2. This angiotensin 2 is a hormone, is a molecule that's going to then trigger other things to happen. So this angiotensin 2 has several target organs. Right? So here, this is how we follow this right here. So angiotensin 2, the effects, antidiuretic hormone is released. So antidiuretic hormone is ADH. So where this angiotensin 2 goes is it signals the posterior pituitary to release ADH. More on ADH in a second. Angiotensin 2 also stimulates aldosterone to be secreted from the adrenal cortex. And the adrenal cortex is the outside part. So this is the adrenal gland. Here's the adrenal medulla where NE and E are coming from. The adrenal cortex is the rind. So the cells in the cortex there are going to release another hormone called aldosterone. Angiotensin 2 then also will stimulate a thirst sensation. Okay. So this makes sense. This of these things, this makes the most sense, right? Is that thirst is stimulated because why? Because you have a lower blood pressure. If you then drink water, you're going to increase the plasma. You're going to bring that blood volume back up. You're going to bring your blood pressure back up. So all of these things, right, this one makes the most sense to you probably. This aldosterone and this ADH make a little bit less sense, but they're trying to, trying is the wrong word, but the effects of ADH and aldosterone are going to be this, right, that they eventually increase blood pressure, increase the blood volume. So how might pressure be increased? Well, ADH is going to cause vasoconstriction. Causes vasoconstriction. Aldosterone increasing the blood volume. Aldosterone signals the kidneys to hold on to water, so you're not urinating as much. This ADH also has this similar effect, an antidiuretic hormone. A diuretic is something that's going to make you urinate, some chemical that will make you produce more urine. So antidiuretic hormone stops that production of water. So these things will then lead to this increased blood volume, increased blood pressure. Right? So that's a lot. You probably need to summarize that, write that down in some other way. Lower blood pressure also signals the kidneys to release EPO. And so this is 1, this is 2. So EPO is erythropoietin. And erythropoietin will stimulate red blood cell production. So you increase red blood cells, you're going to then, of course, increase the blood volume by increasing the hematocrit. Right? So you have cells per plasma. That's going to increase that blood volume, bring that pressure back up. Okay. So a good idea to pause there. So again, there was a typo here, so this shouldn't, your printout probably says decreased or lowered. Here you want to make sure that that says increased. Sorry about that. So this is the hypertension situation and regulating that. So here's the stimulus here. So you have increasing blood pressure, increasing blood volume for some reason. Right? This stimulus, right, will cause the release of ANP, this atrial natriuretic peptide, from the cardiac muscle cells. So not only will those cardiac muscle cells contract, but they also release this ANP in response to an increased blood pressure. So this ANP goes into the bloodstream and then has several responses here, several target organs, right? One, increased sodium loss in the urine and increased water loss in the urine. So these are both in the kidneys, right? So ANP will tell the kidneys, hey, get rid of more water. So you start urinating more. If you're urinating more, your blood is becoming thicker. That's going to decrease that blood volume. Right? Makes sense that you reduce your thirst. You're not drinking as much. That's going to help bring that down. Right? And then really, this ANP plays inhibitory roles of ADH, of aldosterone, right? Epinephrine, norepinephrine. So everything that we discussed on this slide here, all of these are inhibited by ANP. Remember that all this stuff is to bring the blood pressure back up. This then is trying to get the blood pressure to come back down. Right? So you have the inhibition of all these things, and then for this peripheral vasodilation, right? So you make your blood vessels go from this to this, and of course this reduces the friction, and you get more blood flow. Right? That is going to bring the overall volume and pressure down, right, in the system. Okay. So all of these then, I guess, a combined effect of reducing blood volume, that's going to bring that blood pressure back down. Okay. Now, that is a ridiculous amount of information, so it takes a lot of progressing or processing on your part. So endocrine hormonal mechanisms responsible for cardiovascular regulation. So that's that. Thanks for listening. Bring your questions to class or ask them now if you're here. Oops. End show. Keep clapping.